Guys, let's find the x and y intercepts of f of x equals 5x squared plus 12x minus 1. Now, what's different about this problem? It's a quadratic equation still, but now it has two variables. You can think of the f of x as y, right? So you can think of this as y equals 5x squared plus 12x minus 1. All the other examples we looked at today have just one unknown, right? This one has two unknowns. That means this guy graphs to be a curve in the xy plane. And in fact, if you graph it, which we can do, we'll learn how to do it by hand later on, in case you were worried. But we can do it on the graphing calculator just right now to see what it looks like. So in the graphing calculator, if you have like a TI calculator, you go to y equals, erase what's there if you have something else there. And just under y1, I'm going to punch in 5x. I'm going to go to the x squared to square it, plus 12x minus 1. And then what I'm going to do is I'm going to go to zoom, which is in the middle key up here, and go to number 6, which puts it in a standard screen, which goes from -10 to 10 on both axes. Now, if your graph doesn't fit well in that standard screen, then you have to adjust the minimum and maximum values on x and y. But let's see if it does. So we're going to try graphing this. And it does fit pretty well. So it graphs to be a kind of a U shape, no tail, but kind of a U shape, right? And that's typical of quadratic functions. In fact, every quadratic function we look at is either going to look something like that. It might be wider, a little bit wider or skinnier, but it'll look something like that, or it'll be upside down. If A is negative, it turns out you get the upside down U shape. And that shape's called a parabola. We talked about that a little bit yesterday. Yeah, it sounds like a virus, right? The parabola virus. But it's not. It's just a shape of a graph. So, okay, think about what we did with lines. We found x and y intercepts of lines, right? What did it mean when we found, say, the x-intercept of a line? What was, graphically, what did it mean, you guys? It's the place on the graph where the graph crosses where? The x-axis, right? And by the y-intercept, we meant the place on the graph where the picture of the graph, the line usually is what we used to talk about, cross the y-axis, right? X and y-intercept. There's no reason why this graph doesn't have two x-intercepts, in fact, and one y-intercept. So, look, where are the x-intercepts going to be? Well, unfortunately, there's two of them. One looks like it's here, right? The other one looks like it's real close to 0, 0, but I don't think it is. It's over here. And then the y-intercept actually is going to be right there. So that's the y-intercept. And then whatever that is going to be one of the x-intercepts. And then whatever that is going to be another x-intercept. So you can have up to two x-intercepts when you're talking about a quadratic function. By the way, is it a function? Does it look like it passes the vertical line test? You bet. That's why we call it a quadratic function. So we're going to find these right now. That's what we're going to do to close out today. We're going to find the x and y-intercepts. Okay, let's start with the y-intercept because it's easier. The y-intercept, remember what you do to think about a line. If you were asked to find the y-intercept of a line, what would you do? You'd plug in 0 for x. Same thing here. Because at the y-intercept, no matter what graph you're looking at the y-intercept, x has to be 0. And you can see that at the picture, right? You're on the y-axis at the y-intercept, so right here, so x has to be 0. So let's start by finding the y-intercept, and then just as a reminder, you set x equal to 0, and if you're not dealing with an x value as your input, you set the input equal to 0, whatever it is, to find the y-intercept, or the vertical axis intercept, if you want to call it that. What happens when you plug in 0? Well, I'll point right here. What happens when you plug in 0? Do you guys see why it's pretty easy to find the y-intercept? You get 5 times 0 squared plus 12 times 0. those are both 0, right? Minus 1. So negative 1. But if we express it as an ordered pair, what's the y-intercept? 0, negative 1. Well, that's exactly what that looks like, right? 0, negative 1 is your y-intercept. The x-intercept, not quite as easy. So the x-intercept, what do you set equal to 0 to find the x-intercept, or intercepts in this case? You set y equal to 0. And you end up solving a problem that we already solved, I think. 0 is equal to 5x squared plus 12x minus 1. I think we solved it earlier, but we called it y instead of x. Yeah, there it is. See it? So it's going to be the same. So did you guys see all I did was change it to x? So it's going to be the same answer as earlier. I don't think there's a reason to dwell, right? I'll just copy and paste the answer. So what do you have to do here? If we hadn't already done it, you'd have to use the quadratic formula, QF. That's what the dot, dot, dot means. And you get this. But then what would your x-intercepts be? There'd be 2 of them. What would they be? I'm going to put the smaller one first. Negative 6 minus root 41 over 5, comma 0. So my guess is that's this one that I'm pointing at right there. And then negative 6 plus root 41 over 5, comma 0. So these would be your x-intercepts. This is your y-intercept. Before I let you go, I've got 2 minutes. Let me show you a really cool way on the calculator to verify that you've got the right, another way, in addition to what I've already shown you by checking your answers, another way to verify graphically using the calculator that these intercepts works. I'll just do it with one of them since I don't have time to do both. So if you hit the trace button and then you see these guys pop up, hit the trace button. You can plug in any x value you want. You could plug in 5, see what you get when you plug in 5. Y is 184 when you plug in 5. I'm going to plug in negative 6 plus root 41 over 5, and I better get something really close to 0, or, well, hopefully 0 itself, or really close enough that the calculator doesn't know the difference. So I'm going to plug in, in parentheses, I'm going to plug in negative 6 plus root 41, whoops, close parenthesis around the 41, close it around the numerator, divided by 5. So that's what I'm plugging in for x. And then when I hit enter, if I'm right, the cursor should go to the right-hand x-intercept. So I hit enter. I do get y equals 0, so that tells me I'm right. And notice the cursor lands right on that intercept, which is, so you're essentially checking your answer using the graph and the input function on the graph. Okay?